Okay, so today, before we begin, there are a few things I need to mention. So, for you to be good at machine learning, you should also be good at exploratory data analysis. So, the first step will be to understand your data fully. So, I have some few notes here that you can go through. So, these will be notes that will take you back to what you've been learning. So for example, checking your data size, checking if your data has missing value, checking if your data has duplicates, checking the distribution of your data, doing visualizations and coming up with insights. So doing things like checking for correlations and all that. So today we are going to look at supervised machine learning models, and as we said yesterday, these are models that have an input and an output. So we know the label of the input. Okay, and what we are going to look at today is the introduction to regression analysis and simple linear regression. So already you've been taught how you can create regression models in Excel. So my task here will be to show you how we can do the same using Python. So linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variable. So if we have a single dependent variable, then this is a simple linear regression task. If we have more than one independent variable, then this will be a multiple linear regression task. So it is a powerful tool used in predictive modeling and data analysis. So in this section, we will discuss the basics of linear regressions and its applications. So some of the key concepts you need to understand is the dependent variable. So what is a dependent variable? What is an independent variable, and what are the regression coefficients? Okay, so those are the things you need to understand. So a dependent variable is one that depends on other inputs for it to be formed, and then the independent variable is not dependent on any other value for it to be formed. So let's go into the introduction to regression analysis. So I'm going to go through the content that is over here, so which is basically theory, so for you to understand. So just to give you a refresher as to what regression analysis is. So regression analysis is a statistical method that is used to model the relationship between a dependent variable and one or more independent variable. The goal is to predict the value of the dependent variable based on the value of the independent variables. So regression analysis can be used for both continuous and categorical dependent variables. So I believe you all know what continuous variables are. So continuous variables are those that change over time, and categorical dependent variables are those that change in, so the change is not that much. So for example, 1 to 10, so those can be considered as categorical variables because we only have values from 1 to 10. But continuous variables are those ones that change, maybe from 1 to 100 to 1000, so something like that. So those are continuous variables. So regression analysis can be applied to various types of data, such as time series data, cross-sectional data, and panel data. So there are several types of regression analysis. So we have simple linear regression being one of them. We have multiple linear regression, polynomial regression, logistic regression, and nonlinear regression. So in this course, we will be looking at simple linear regression, multiple linear regression, and logistic regression. So one thing you need to note is for linear regression, multiple linear regression, and polynomial regression, these are for regression tasks. So we have, so inside supervised learning models, we have regression and classification tasks. So these three here perform regression tasks, so which means they deal with continuous data. Then logistic regression over here deals with categorical variables. So here we will be doing what we call classification. So yeah, let's proceed. So in simple linear regression, there is only one dependent variable, and the relationship between the variables is assumed to be linear. Okay, so I won't go through the rest, but you can try go through it at your own free time. So let's proceed on to the next thing, which is simple linear regression. So how do we perform simple linear regression? So I won't go deep into the theory part because I want to show you guys the practical part. So what you can do on your side is you can go ahead and open your Jupyter notebooks. Okay, so for me, I'll open my Jupyter notebooks. So mine won't be same to yours, but they will be similar in a way. Hello, yes. I see someone has a question. Okay, so that's okay. So I think that's from an AI bot, so you don't need to think much about it. So this is a new folder, so we will be using this folder for you guys. So let me open it independently. Then this is where I'll have all your notebooks. So on your side, you can go ahead and create a new IPYNB file, and this will be simple underscore linear underscore regression. So this is our code notebook for today. So if you have your Jupyter notebook running, so we are going to discuss the simple linear regression part. So the first thing we are going to do is we are going to import pandas. So we are going to import some libraries. And the first library we are going to import is the pandas library. So import pandas as pd. Then we are going to have import numpy as np. So for now we will have only those two libraries. Then as we proceed, I'll add more, and then I'll tell you what we're doing. So go ahead and import the two libraries. So hope you can see my screen. If not, you can request I zoom in a little bit. So let me check. So I think my screen share is okay, so we can work with that. So once we've imported the libraries, what I'm going to do is I'm going to create a dummy data. So this is for simple linear regression, because I believe in the real world you'll never have a situation whereby you will be required to like run a simple linear regression model. So here I'm going to create some dummy data, and with this dummy data we are going to make some predictions. So here I'm going to create a dictionary. So I'm going to have my data dictionary being equal to, So here I'll have my column X, and column X will have the values 1 2 3 4 5 6 7 8 9. So that's my column X. Then next we will have my column Y, and Y will have the values, let's say 2 3 4 5 6 7 8 9 and 10, so something like that. Or let me make these into 10, so 20 30 40 50 60 70 80 90 then 100. So you can go ahead and copy that, then we can proceed. So I think my connection is not 100%. Yeah, but I'll try fix that in the course of the week, so I apologize for that. Okay, so go ahead and copy this. So we've imported the numpy and pandas library. Actually, numpy is not that much relevant in this case, but we need the pandas library to create our so we need the pandas library to create our data frame. So here I've created my data dictionary with the X and Y values. So here X is the target variable, not X, so Y is the dependent variable, then X is the independent variable. So that's what you need to know before we can proceed. Then what I'm going to create is my data frame. So we're going to have our PD being equal to pd.dataframe, then we pass in our data dictionary. So go ahead and copy that, then we can proceed. And if I do df.head, that's what we get. So we have our X and we have our Y. Okay, so that's the code. So you check it out, then we can proceed. Okay, so that should be enough. So for us to learn a simple linear regression model, we need to import a library. And when working with Python, so creating machine learning will require you to work with the sklearn library. So here I'm going to import linear regression from sklearn. So we'll have from sklearn dot linear underscore model import linear regression. So note here L is capital L and R is capital R. So that's what you need to note. So after importing your model, so what do you do next? So the next thing you do is you instantiate your model. So it's like calling your model, and we were going to say LR, standing for linear regression, should be equal to linear regression. So these will be the steps that you will be following when creating machine learning models. So the first step is importing the model you are going to use. The second step is instantiating the model we are going to use. So we have several models, and one of the models that I'm introducing today in class is the linear regression model. And from the linear regression model, we will run the simple linear regression. So for example, if we come back up here, so we had our value, let's say for example 5 corresponding to 60. So if I was to say something like I have a value 50, so if x was equal to 50, then y would be equal to, so this is just a comment here. Okay, sorry, I apologize for the lag. So I've mentioned that my connection is not okay, but I'll fix that during the week. So yeah, so here we've imported our data. So I was at this part saying that when creating machine learning models, the first thing you do is you import the model that you're going to use. And all models that we are going to use will be from the sklearn library. Okay, and here from sklearn we have a module called linear model, and from the linear model part we import linear regression. So linear regression is the model that we are going to use to create our simple linear regression model. So up here I was saying that, for example, if we had our value x being equal to 50, so what would be your guess for the value of y? So for me, I will say this should be 600. And if my x was equal to, let's say something like 16, so what will be my y? So my y will be equal to something like, so for example, if we have 9 here at 100, so then 16 will be something like 170. So these are just simple calculations. So what I want to see is if I pass in my x and y into this model, will the model be able to come up with these accurate predictions? So will it say my y for 50 is equal to 600 and my y for 16 is equal to 170? So we will check that and see. Okay, so I see I am still lagging. Apologies for that, but I guess the recording won't be lagging, so we will use that. So I'll make these sessions short for now until I have my Wi-Fi connection fixed. So the next thing I'll do is I'll fit the data to the model. So here we will have lr dot fit. Then here I'm going to pick the x column and add it here. So I'm going to have df, then I'll select the x column. So I'm selecting the x column using double squares. So what does the double squares usage mean? So it means I'm selecting this column as a data frame. So this should be capital X. So I'm selecting this column as a series, so but in form of a data frame. But for the single square for the y, it's different from what we're doing there. So here we run lr.fit, then we fit the x and the y part. So we specify our independent variable and our independent variable. So let's run that and see what we get. So if I'm still lagging, let me repeat what I've done there. So here I've imported our linear regression model, then here I've instantiated my model, then here I'm fitting my data to the independent and the dependent variable. So x is the independent variable, then y is the dependent variable. So we have an error here. Let me fix that. So this should be capital X instead. So now we have our model fitted. The next thing, so since we have our model fitted, so this output here shows that our model has been fitted. The next thing we do is we make predictions on data that is not in the data frame. So for example, these two values here. So we can do prediction 1. So x being equal to 50. So here we will have our prediction 1 being equal to regressor.predict 50. Then what we can do is we can print out prediction 1. Then we are going to have prediction 2, and we are going to have our regressor. So we should have that. Then this should be 16. Then let's see what we are going to get for prediction 1 and prediction 2. So here it should be LR, then here it should be LR. Okay, so for 50 we get a prediction of 510, for the other we get 170. So let me remove the warnings first, then I'm going to show you the predicted values. So maybe I was wrong myself, or maybe the model is wrong. Yeah, so here we get prediction 1, so for the 50 value, and we get prediction 2 for the 16 value. So from these output that we have here, we can see that these are values that are close to what I specified here. So for example, for 50, so 5 should be 510 actually. So here I was wrong, so this should be 510. So you see, for me here I made a mistake, and I said that the predicted value for y, if we had x at 50, the predicted value for y will be 600, and if we had x at 16, the predicted value for y will be 170. So I was right in predicting one of the values, but the model proved me wrong on prediction 1, where we have the value 50. So it predicted the value for y, where when we have 50, to be equal to 510. So I'll give you 5 minutes to copy the code and run it on your end. Then we can go ahead and explain what we have here. Okay, so 5 minutes, you copy the code, then I'll explain in detail. So in the meantime, I'll go get some water. If you have questions, you can share in the chat section.
Hi, can we get the first code? I want to take a picture.
Okay, so let me scroll up so that you can see the first code. So 5 minutes we start with this. So at 8:37 I'll scroll down to the next code part. Or what I can do is I can split my screen, then no, but I think splitting is not okay. So just
I'm
copy
okay.
this
I'm
one.
okay. I'm okay on the first. You can go back.
Yeah, so this is the second code. So you can copy the second code down. Okay, so we can proceed. So before I explain what we have here, there are a few things I need to show you guys. So for you to understand the process of creating your machine learning models, so there is this drawing I'm going to do here that will explain the steps of creating your machine learning models. Okay, so first of all we start with our data here. Okay, so maybe I'll say let my data be equal to x. The next step we follow is we process our data. So this I'll give it our value p. Then here I can say x is the data, p is pre-processing, what else? So after pre-processing our data, we split it. So S is split. And what are we splitting the data into? So we are splitting the data into the dependent and the independent variables. After doing the split, so what else do we do? So then next we do the importation. So here we have our y, so we import ML model. So that's what we do next. Then after importing our ML model, what do we do next? We instantiate. So I'll have these as in. So in is instantiate. Model. Then after instantiating the model, what do we do next? We do the fitting. So F here will fit model to the data. After fitting the model to the data, then next what do you do? So next you make predictions. So I'll have predictions as PR. Then after making predictions, what else do you do? So you check for your model accuracy. So that's the last part, but we won't discuss this part for today. So the first part here is the data. So if we go back to, so this first part here, if we go back to our code, so what do you see? Here we created our dummy data, and this dummy data has a column X, which is the independent variable, and we have a column Y, which is the dependent variable. So this is just an example data set. So when we will be dealing with multiple linear regression, we will work with real world data. So that's the data part. And next, what is the next part? So the next part is the pre-processing part. So this part here, so we've not done any data pre-processing for today, but when we will go into fitting multiple linear regression model and working with real world data, we will dig deeper into this part. Then next is this part here, the S. So splitting your data into X and Y. So what I would have done, so for me, I've done the split here. So I've done the split here. So I've split the data into the independent and the dependent variable. But when we will be creating other models, I'll show you how we split them outside the lr.fit part. Then the next thing I've done is the model instantiation. So for the model instantiation, this is the part where we instantiate the model. So we import the model from the sklearn library, then we instantiate it. So after importing it, so the instantiation is just mentioning the name of the library you've imported and adding these brackets here at the end. So inside these brackets, there are a few things we can add in there, but we will discuss that in upcoming classes. Then after that, what did we do? So we've instantiated the model. Then the next part is fitting the model to our data. So this is the fitting part. So you fit the model to your dependent and independent variable. So after fitting, you make predictions. So you make predictions using the model on unseen data, and this is the prediction part. So we won't be following this format maybe in upcoming classes, but since this is a simple linear regression class, I've used this format to show you how the model works. So we've predicted the value for 50 and for 16, which are not in here, but you can see the model is able to understand the trends that are in within our data, and the model is able to come up with these predictions. So it predicts that our value for our y value for 50 is 510 and our y value for 16 is 170. So let's go back to the notes and see what we have there. So I've shown you how these steps are applied, so you'll go through the class recording later on and see them again, but also you can go through the class notes and understand how it works. So let's go through this theory part that is here. So I've already shown you the practical part. So simple linear regression is a statistical method used to model the relationship between a dependent variable and a single independent variable. So it's called simple because it involves only one variable, as opposed to multiple linear regression, which involves multiple independent variables. The goal of simple linear regression is to fit a line to the data that best captures the relationship between the dependent and the independent variable. The line is defined by the equation y is equals to beta 0 plus beta 1 x. So you can think of this equation as something like, so let me create another drawing here. You can think of this equation as being something like y being equal to mx plus c, okay, where m and c are constants, and our aim is to come up with something like this. So for example, if we had data points here, so y is equal to mx plus c would be something like this. So we will have a straight line like that. So this will be our y is equal to mx plus c equation. Okay, so this is basically what we are working on. So this is simple linear regression, but with multiple linear regression this doesn't apply. So with multiple linear regression we will see what applies. So yeah, so y is the dependent variable, x is the independent variable, beta 0 is the intercept, and beta 1 is the slope of the line. The intercept represents the value of y when x is equals to 0. So for example, in this equation that we have here, so if x was equal to 0, so our c here will represent the value of y. So for example 10. So if x will be equal to 0, then our y will be equal to 10. If we go back to our class example here, and let's say we had the equation y is equals to mx plus c, okay, so what will be your y value or your c value? So for example, for me, I can say my c should be equal to 10. So that's just a random guess. And if my c is equal to 10, then what about my m? So my m will be equal to 1. So I believe that's the case, because if we go down here and I run lr.intercept, so you can see our intercept is at 9.999, and if I run lr.coefficient, so I'll explain these later on also. lr.coef, so the coefficient is at 10. Yeah, so something like that. So these are the values that we get from our model, so we can come up with our y is equals to mx plus c equation. So let's go back to the notes and finish this. So to fit the line to the data, we need to estimate values of beta 0 and beta 1. So in Python, this will be done for us by this model. So we don't have to specify the coefficient and the intercept. Then we have this equation that is over here that does all those calculations to determine maybe the beta 1 and beta 0 values. Then here we have example codes for fitting a simple linear regression model. So I haven't shown you how we can evaluate our model performance, but we will do that in a later on class. So that brings us to the end of today's session. So maybe you can ask questions if you have any questions concerning what we've covered today.